Arrays. It's time for another lesson. This lesson is going to be about one thing and one thing only, and that is arrays. In previous lessons, I talked to you guys about primitive data types such as int and char and short and float. And those things are great, but you really can't do any kind of powerful programming if you can't organize those types of data into what's called data structures. And one of the most popular data structures in C is one of the ones that's built into the language, and those are called arrays. And the easiest way you can think of an array is like an array is a group of many items of the same data type into one contiguous block of those items. So like an array looks like this. If you wanted to have an array of ints, for example, you would declare it just like you declare the array, but you would put square brackets in there and declare the number of elements of that array that you want to create. And let's start with something smaller than 100, say 10. And like normal variables, arrays can be initialized. What you do is you create an initializer list, though, and you put in the elements of the array. So I'm just going to be boring here and put the number of items in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's the array. Arrays are useful in the sense where you want to deal with a lot of data and you want it to be properly organized. It's a mistake when you're dealing with a lot of numbers, especially if they are a group of them to declare variables without an array. For example, you wouldn't want to do something like this unless there were only like 3 or 4 of them, because how would you index these based off of which one you wanted to get at runtime? It would be very difficult. So some basics of arrays. Once you have your array declared, you can access an individual element by typing the array name and then just the indexer. In C and most modern programming languages, the arrays are indexed starting at 0, which is very important. So if you want to get the first element, you go for 0. And very important, if you want to get the last one, you do not put 10 in there. You put 10 minus 1 or the number minus 1, because your 0 counts. The 10th element will be the 9th if the array count is 10. If you start going after 10, you're going outside of the bounds of the array, and that's asking for your program to crash, which is a very common mistake. I'd say like C programs, I'd say at least 10% of all crashes or more because of people going outside of the bounds of an array, which is going outside of the bounds of memory, and it's bad. So just going to run this real quick. Show you guys the elements of the array. So that's how you access the element of array. Assigning them is the exact same idea. So if I wanted to assign the 0th one to something crazy like, I could do that, and then print it out like so. Okay, so that's the way arrays work. What's the real power of an array? The best way to think about it is, well, I always think about game programming because I'm a game developer. So I think of arrays as like groups of things that you want to have control over to increase the complexity of a program. So for example, you might have an array of enemies in your game if you have a bunch of enemies. You might have an array of game players, or an array of bullets flying through the air, and so forth. So they're very useful. So if you wanted to process the whole array at once, the quickest way to do that's with something I showed you from earlier lesson, flow control structure called a for loop. So what you usually do is you create an index, and you index through the array. It's very important that if you're iterating through an array that you do less than the number of items in the array and not less than or equal to, because you want to stop at 9 and not 10 like I was talking about. So if we just wanted to print out all the elements of the array, we would do something like this. And this is pretty boring. You get the idea. And they are, so use the elements of the array. If you want to change them, same idea. Because I want every element to contain the index times 2. I could do that. And that works. So what's something useful? I don't want to get into too much crazy stuff during this one thing, just to talk about basics of arrays. Arrays all have to be the same type, so I can't just suddenly expect this to be a float in the middle of here. This has to do with the way RAM and memory is laid out contiguously inside the computer, which I'll go over later in a later lesson about memory management and dynamic memory later. A common thing that people will typically do with an array is compute various things. So for example, if I wanted to have a function that would return the maximum number, the highest number in the array, I could write a function that takes the array as an argument and returns that value out. When passing arrays as arguments, they usually look something like this. If you put this in here, I think you'll get a compiler error. Maybe not. I'm not done here yet. I'm just putting a placeholder. Okay, so that'll work. But typically when you're passing arrays as an argument, you leave the square brackets out. So yeah, I'm going to go ahead and get the maximum element of this array, the highest number in there. The way I'm going to do that is I'm going to call the function before I'm even done with it. And I'm going to call it like so. And this should compile without any errors. And then I'm going to write it. So getting the maximum, pretty simple operation. First you want to declare your int, which will serve as your return value. And you want to initialize that with something low. Something low is important because you are going to, over time, make sure that becomes the largest value, and you don't want it to start out being higher than any element in your array. So same idea, for loop. This function has no idea how many elements there are in this array, so I'm going to add a second argument telling me how many elements there are in here. And that'll help me figure out how to compute over this element array. There's no way to find out how many elements there are in an array just by the array itself. You need this second argument. It's very important. And we're going to iterate through. So I'm going to use another thing I showed you last time, the friendly if statement. If the array at I, the current element, is greater than our would-be maximum, well, then the would-be maximum better become this element. And as we go through each iteration of this array, every single time up until the point of I has been computed to, ret, or my return value, becomes the largest element in the, up into I. And then when we get to the end, it's just the largest element in the array. So now we've written this little Swiss Army knife utility maximum function, which will return maximum number in an array. So I believe we're going to get 10, because that's the highest one. And we did, but I'm stupid and I left off this thing. There you go. Man. There, 10. Maximum element is 10. If I was to make any of these items really high, that would become the new maximum, as you see here. So I got a few minutes left. What else can I talk about with arrays? You can change their types. So this is kind of boring, but suppose I wanted to use up less storage. I could change everything in here to be a short instead of an int. And I have an array of shorts instead of ints. I don't remember what the thing is for short. I haven't done short like in a really long time. Oh, I guess it's that. Okay. %I is for short. And same idea, shorts instead of ints. Don't really. I guess you probably already knew that, but yeah. Keep in mind, n is still an int because that is the number of elements in the array, and that number could be higher than a short if I had, say, more than 65,000 items in here. So what exactly are arrays? This is important. Arrays are basically, well, that gets into dynamic memory management, which will come in a later lesson. But for now, it's important to remember that when you pass an argument to a function, a lot of times that argument is copied in. The best example is I can change n here to any number I want, and that won't modify the argument passed in. Like if they are passed, so that passed in is called by value when it's like this with a primitive type. Primitive types are passed in by value. Arrays are passed in by a reference to the array. So this name is actually a reference to the array's memory. It's very important. The reason why that is important is if I got crazy inside Max and did something wrong, decided to change the array from within this function, then by calling this function, I actually have changed that element. And I have basically created a side effect. Stupid backslash n, I'll kick its ass. I have changed and affected the state of the array. A lot of times programmers will safeguard against this. If they never tended to change anything, they'll throw the word const in front of the array, making this line right here a compiler error and saving you from making these kind of mistakes. So that's the basic idea of arrays. They're useful if you want to have many, many, many things and you want to work with them using for loops or really anything, indexable stuff. I'm going to go ahead and end it here, and next lesson I'll talk about structs, which are another data structure that's native to C. Thanks for watching, guys. Catch you next time.